presentation, how Continental develops advanced approaches to data-focused operations using AWS technologies. This presentation was jointly prepared with Dr. Thomas Kleinert of Continental AG. Unfortunately, he cannot be here today due to health reasons, so I'm trying to do my best to fill in his place. Obviously, we would prefer to have the customer on stage because this is a project that Continental built, and Continental knows best why they did that and what's the value proposition for them. Let me quickly introduce our customer, Continental AG. Probably most of you know, Continental is a global automotive manufacturing company with a strong portfolio in mobility solutions, tires, surface materials, with overall close to 200,000 employees globally. Last year, Continental AG had a combined sales of 41 billion euros, 200,000 employees, and operated more than 500 locations globally. Continental businesses are organized into 3 group sectors. 49% of this business is the automotive sector, where Continental is a leading tier 1 supplier to the automotive industry. The project we are covering today is located in that business sector and is concerned about automotive manufacturing. So, what is the mission of FactoryOS? If you're a manufacturing company the size of Continental, you are operating dozens of manufacturing sites globally, each site with thousands of machines and hundreds of thousands of sensors. And having this global footprint brings certain challenges if you want to modernize your manufacturing applications. So, starting point, more than 50 locations globally with a vast park of manufacturing equipment from different vendors with different interfaces and different protocols. And Continental wants to modernize their manufacturing applications, reuse solutions across the different locations, be more efficient and more agile in their operations. So, the goal is to develop applications across this global footprint with a very heterogeneous infrastructure part. Now enter FactoryOS. FactoryOS is the factory operating system that builds a middle layer between the shop floor and the IT, the applications, that allows Continental to efficiently reuse software assets across their manufacturing estate. We have the mission statement of FactoryOS, and I mention that because there is a speciality to that approach. Create a transparent, accessible, scalable data platform to enable, and now this is the peculiar part, independent, event-driven and event-sourced applications based on the shop floor. We will revisit that event-driven and event-sourced part and why this provides genuine advantages in manufacturing applications. But first, let's review a bit our collaboration between Continental and AWS. We have a mechanism that's called working backwards, which is helping to innovate with and on behalf of the customer. Working backwards was originally implemented inside Amazon.com to understand customer pain points and customer demand, and then, based on those customer needs, develop a vision for a solution and phrase that vision in the form of a press release from a future point of view. So we take the customer requirements, envision how a future solution could look like 3 years or 5 years from now, and then write this fictitious press release statement. And that's then the guiding principle to solution and implement the actual product or service. So this is not only applied inside Amazon or AWS, we also do that jointly with our customers, and that's the journey we embarked on together. That we first had workshops to frame the problem statement and to understand the challenges of status quo. Then we envisioned potential solutions, tried to dive deep into the different user personas and how the solution should look and feel for them. And based on that, we jointly wrote that press release and an FAQ document which addresses the most relevant questions for that specific solution. This is accompanied by visuals that depict the user experience of the target solution, how the users would experience the solution. So I guess that explains what we mean by starting from the customer and working backwards on how to solve customer problems. But we don't stop there. After that innovation step and envisioning, we jointly embarked on the journey to implement this solution. First, obviously, we also took best practices to de-risk the solution by doing a technological and commercial feasibility analysis. And then Continental opted to work with our professional services to implement a first minimal viable product, which was kicked off via a hackathon and then joined in a co-development phase. So let me talk a bit about the technology behind that. The path to MVP. As I said, we start with customer pain points, and this is what Continental shared with us. As of today, in the shop floor, there is massive amounts of data, mostly in the type of raw events. Now, if you want to build those Industry 4.0 use cases, you typically are challenged with getting access to the data because you have the global footprint of factories and you probably need access to a lot of different data sources. How would you do that efficiently? So there's no official data interfaces to tap into all of those shop floors. The standard approach is typically to tap into manufacturing execution systems or the manufacturing data lake that already exists on AWS. But Continental automotive teams have shared with us that only a small part of the relevant data is ingested into manufacturing execution systems. The majority of data is not stored long-term and is lost for those downstream applications. There's also further challenges about missing data the latency introduced via the detour over MES, and also that the data format of the MES typically is not optimized for what you want to do with your applications. So what happens many times is that projects build unofficial interfaces to access data. So not supported by central teams, difficult to maintain once you have changes on the shop floor, and also inefficient in terms of reusability because they are built on a one-off basis from project to project. So against that backdrop, FactoryOS set out to have this integration layer that would make data accessible widely inside the company. And now we come back to event sourcing, because making data accessible needs more specification, right? Which kind of data in which form? So let me quickly introduce the ideas of event sourcing. This example is not from the shop floor, but it's coming from the domain where event sourcing was initially coined, software engineering. In this case, an example from e-commerce. So let's assume there's a web shop and I have a customer that is a golf player. And this customer enters the web shop and then adds some golf balls to the web shop cart. And then he sees some golf clubs that are very fascinating and he adds those as well. And then he proceeds to checkout. So last minute at checkout, he reconsiders the choice and removes the golf clubs because they are probably outside of his budget. Instead, he adds another set of golf balls and then finalizes the checkout, and the order is persisted to the ERP system. So why am I telling this story, right? There is the two paradigms next to each other. The ERP system would be a stateful data model that just has the final order with the product purchased and the payment details. But the event-sourced model has more history. It transports the information that initially the customer was also considering the golf clubs and then removed it again from the cart, which probably is relevant for future purchases. So, in a nutshell, event sourcing will give more detail typically than a stateful data model that only displays a snapshot at a certain point in time. So what does that mean for manufacturing? In manufacturing, the stateful data models would probably live in those systems on the top. ERP, MES, databases, and FactoryOS tries to provide more than that. FactoryOS wants to be an audit trail of all the events that led up to certain states. So the idea would be to collect the raw events on the shop floor in those global factories and on demand make those accessible to the application developers. Do not get scared by that architecture. I will walk you through, right? This is what the team has then built, and in essence, it's a highly scalable serverless architecture that massively builds upon serverless concepts. So you will find a lot of AWS Lambda, simple queuing service, And these pipeline building blocks that are used both at the ingest, at the transformation stage, and at the consumption stage. So that gives the projects the flexibility to quickly create new pipelines with the project-specific transformations that make the event streams highly useful for each respective project. Let's do a use case example. So that was the world prior to FactoryOS. Let's say we have 3 applications: central monitoring, self-service BI, and a notification system. So typically, the first system would have started to build a custom data pipeline that ingested data from the shop floor for one purpose. And then the second project would come along and say, like, can we please also access your data source? Because that would be more efficient than collecting it from the shop floor ourselves. Now there's already a small challenge, right? Application 1 will have optimized their data structure for their use case, which is probably not exactly what application 2 would need. And secondly, application 1 has sized the infrastructure according to their needs. So now there's an initial use case with probably highly variable load, and we need to make sure that use case 2 does not impact the availability of use case 1. And also, maybe use case 3 has a completely different requirement on latency, because the monitoring has dashboards that are refreshed at an hourly level or a minutely level, but our real-time notification system would need seconds latency, which would push the data source to limits. So instead of this, FactoryOS will have a different situation. The platform provides that event stream. It centrally ensures that shop floor events arrive in the platform, but it doesn't make assumptions on what's the right format for those applications, how should we filter or aggregate. That will be delegated to the respective projects. So each application team will work on those event streams and transform the events according to their own needs. In that way, we have broken up the cross-dependencies and allow teams to quickly build applications without waiting for each other. So that is the value add of event sourcing in the shop floor, that you can delay the decision of the right data structure to a point in time when you actually need the requirement, when you actually know the requirements of your applications. Let me put that into perspective from an AWS point of view. We have this value proposition of streaming data for manufacturing use cases. A lot of AWS customers know that data is an enabler and that they need data to digitally execute their workloads. And data streaming provides the right means for this massive scalability, the low latency, and also the fine-grained access control. At the bottom, you see high level how streaming pipelines would typically look like. And now if you reflect back on what I've told you about FactoryOS, we can agree that FactoryOS implements exactly those stages. So this is AWS streaming, which talks about the infrastructure layer. FactoryOS, on top of this, answers the question how the application layer should look like. What data should be streamed to efficiently build applications for the manufacturing shop floor at scale. So this is why we are excited about that project and the novel approach to focus on event sourcing in the shop floor in that way that Continental FactoryOS is doing. Thanks for your interest.